Let's get some practice rewriting definite integrals as the limit of a Riemann sum. So let's say I wanted to take the definite integral from pi to 2 pi of cosine of x dx. And what I want to do is I want to write it as the limit as n approaches infinity of a Riemann sum. So it's going to take the form of the limit as n approaches infinity, and we can have our sigma notation right over here. And I would say from, let's say, I is equal to 1 all the way to n. Let me scroll down a little bit so it doesn't get all squunched up at the top. And so let me draw what's actually going on so that we can get a better sense of what to write here within the sigma notation. So let me do it large. So if this is pi right over here, this would be 3 pi over 2, and this would be 2 pi right over here. 2 pi. Now what does the graph of cosine of x do? Well, at pi, cosine of pi is -1. We'll assume that's -1 there. And cosine of 2 pi is 1. And so the graph is going to do something like this. And this is obviously just a hand-drawn version of it. But you have seen cosine functions before. This is just part of it. And so this definite integral represents the area from pi to 2 pi between the curve and the x-axis. And you might already know that this area is going to be, or this part of the definite integral will be negative, and this would be positive, and they'll cancel out, and this would all actually end up being 0 in this case. But this exercise for this video is to rewrite this as a limit as n approaches infinity of a Riemann sum. So as a Riemann sum, what we want to do is think about breaking this up into a bunch of rectangles. So let's say, or I should say n rectangles. So that's our first one right over there. Then this might be our second one. And let's do right Riemann sum, where the right boundary of our rectangle, what the value of the function is at that point, that's what defines the height. So that's our second one, all the way until this one right over here is going to be our nth one. So this is 1. Let me write it this way. This is I is equal to 1. This is I is equal to 2, all the way until we get to I is equal to n. And then if we take the limit as n approaches infinity, the sum of the areas of these rectangles are going to get better and better and better. And so let's first think about it. What is the width of each of these rectangles going to be? Well, I am taking this interval from pi to 2 pi, and I'm going to divide it into n equal intervals. So the width of each of these, is going to be 2 pi minus pi. So I'm just taking the difference between my bounds of integration, and I am dividing by n, which is equal to pi over n. So that's the width of each of these. That's pi over n. This is pi over n. This is pi over n. And what's the height of each of these rectangles? And remember, this is a right Riemann sum. So it's going to be the right end of our rectangle is going to define the height. So this right over here, what would this height be? Well, this height, this value I should say, this is going to be equal to f of what? Well, this was pi, and this is going to be pi plus the length of our interval right over here, or the base of the rectangle. So we started at pi, so it's going to be pi plus, this one's going to be pi over n, I could say times 1. That's this height right over here. What's this one going to be right over here? Well, this one is going to be f of pi, our first start, plus pi over n times what? We're going to add pi over n 2 times. Pi over n times 2. So the general form of the right boundary is going to be, so for example, this height right over here, this is going to be f of, we started at pi, plus, we're doing the right Riemann sum, so we're going to add pi over n times by this point. Pi over n times n. Or, if we wanted to say it generally, if we're talking about the ith rectangle, remember we're going to sum them all up. What's their height? Well, the height is going to be, in this case, it's going to be cosine of pi plus, if we're with the ith rectangle, we are going to add pi over n I times. Pi over n times I, and then that's the height of each of our rectangles. And then what's the width? Well, we already figured that out, times pi over n. And if you want to be careful and make sure that this sigma notation applies to the whole thing, there you have it. We have just re-expressed this definite integral as the limit of a right Riemann sum.